In this session, we are going to discuss about the asynchronous binary up counter. So, asynchronous binary up counter counts the clock pulses in the incrementing order. So, how asynchronous counter count the clock pulses, we will see now. See it now. Asynchronous means when all the flip-flops are not connected to a common clock signal, and all these flip-flops are not triggered simultaneously with the clock input, then it is called asynchronous, because only the first flip-flop, if you see the block diagram of the asynchronous binary up counter, okay, so only the first flip-flop, it is connected to the clock input which is to be counted, okay, and the remaining flip-flops, the second and third, all these clock inputs are connected to the state change outputs of the previous flip-flops. This is the previous flip-flop for this one, and its state change output is nothing but Q0. Q0 is connected as the clock input to the second flip-flop, and Q1 is connected as a clock input of the third flip-flop. Okay, first of all, we will see the construction, how the asynchronous binary up counter is designed. Generally, here we are discussing about the 3-bit asynchronous binary up counter. Okay, so first we'll see 3-bit asynchronous counter, then we'll see the up counter, how the up operation, counting up operation is being performed. We'll see afterwards. Okay, first we'll see the asynchronous counter. Since this is asynchronous counter, and that too 3-bit asynchronous counter, okay, so it is designed by 3 T flip-flops. Okay, so as I told earlier, all the counters are designed by flip-flops only, and that too the counters used are the flip-flops used in the counters are either JK flip-flops or T flip-flops. If you use JK flip-flop, simply we have to short the J and K inputs, and that input is taken as T, that is nothing but toggle input. Okay, so and sometimes we may use D flip-flops also as counters. Their construction is different. We will discuss it later. Okay, so now in this session we are using T flip-flops as the basic elements of the counter. And here, if you observe, all the T inputs of the flip-flops are tied to a common input signal, which is nothing but 1. Means when the 1 is connected to T input, this flip-flop will operate in toggle mode. Toggling means the output will change its state when the input clock pulse is going to be triggered. Okay, so now we have seen how the asynchronous counter is designed. Okay, so in the 3-bit asynchronous binary counter, we have three T flip-flops, and all the T flip-flop inputs are connected to logic 1. Okay, and all are here negative edge triggered. All the flip-flops are negative edge triggered. And one more very important point is, all the flip-flops are not commonly connected. I mean, all flip-flops clock inputs are not commonly connected to a common clock input signal. Okay, so here only the first flip-flop clock input is connected to the original clock pulse, which is to be counted, whereas the second, third, and so on, how many may be the number of flip-flops, their clock inputs are connected to the state change output of the previous flip-flop. Okay, state change output of the previous flip-flop. So I already told that the second flip-flop clock input is connected to Q0 output of the first flip-flop, and third flip-flop's clock input is connected to the Q1 output of the second flip-flop, okay, and so on. So this is general construction of asynchronous counter, okay. And now we will see what is binary up counter, okay. So up counter means it counts the clock pulses in incrementing order, okay, from 0 to the maximum value. So 0 to maximum value means in this case here we are using 3-bit counter. So the maximum count will be 7, from 0 to 7, which is nothing but 2 power n minus 1. 2 power n is 3-bit means n is 3. So it is 2 power 3 minus 1, which is nothing but 8 minus 1. It counts from 0 to 7 only. After 7, again the output is reset back to 0. That's why it is called binary up counter. Now we'll see the construction of the up counter, okay. So in this construction, the first T flip-flop input is clock input is connected to the clock pulse to be counted, and the second T flip-flop clock input is, if it is connected to the Q0 output of the previous flip-flop or the first flip-flop, then it is called the binary up counter, okay. Similarly, the second flip-flop clock input is connected to the Q1, means second flip-flop output, that is then means in the up counting process Q output is connected to the clock input of the next flip-flop. Now we'll see the counting operation, how it operates, okay. So now if you observe the truth table of the counter, in the initial condition, the output of the all flip-flops are 0 0 0, which is in reset condition, okay. So when the first clock pulse comes, the Q0 will be toggle, because when the first clock pulse comes, during the negative edge of the first clock pulse, the Q0 output will be toggle, means 0 become 1, okay. So similarly, when the second clock pulse comes, again second clock pulse, during the negative edge of the second clock pulse, again the Q0 will be triggered, and now it will change its state from 1 to 0. Similarly, when the third clock pulse comes, only the first flip-flop goes on changing its state from 0 to 1, 1 to 0, 0 to 1, 1 to 0, and so on, okay. Whereas since it is asynchronous binary counter, so no other, means Q1 or Q2 outputs are not being reacted by the input clock pulses, okay. So the Q1 output changes only when its clock input, which is connected to the output of a Q0, okay. So changing its state from 1 to 0, because it is negative edge triggered. So the second flip-flop will be triggered when the first flip-flop Q0 output is changing its state from 1 to 0. So from the first bit, if you observe, okay, when the first clock pulse comes, the first flip-flop output is changing from 0 to 1. So 0 to 1 transition is not recognized by, or not going to trigger the second flip-flop. That's why its output will remain same. And when the second clock pulse comes, means the state change from 1 to 0. Q0 change state is changed from 1 to 0. So which is nothing but negative edge trigger pulse. So it is going to trigger the second flip-flop. That's why the second flip-flop will be toggle, and its output is changing from 0 to 1. When the third clock pulse comes, the first flip-flop output is changing from 0 to 1, means positive change, 0 to 1. So for that change, there won't be any change in the output of, means it won't trigger the second flip-flop, thereby the output will remain same. When fourth clock pulse comes, then the 1 is toggled to 0, 1 is changed to 0. So it is changing its station from 1 to 0, which is nothing but negative triggering. So the second flip-flop will be triggered and it changes its output from 1 to 0. It is toggled and changes output to 1 to 0. Similarly, when the fifth clock pulse comes, it won't change its output. When the sixth clock comes, it is changing its transition from 1 to 0, so it is changing. Okay, like that. Q1 means the second flip-flop output is toggle whenever the first flip-flop output is changing its state from 1 to 0 or negative urge, during the negative urge. Okay, and similarly the Q2 output is going to, means that the third flip-flop is going to change its state when there is a change in the output of Q1 from 1 to 0. Okay, so from the first cycle onwards, first clock pulse onwards, if you observe, okay, so there is no change in the output of Q1. So from 0 to 0 there is no change. That's why there won't be any change in the output of Q2. So when the Q1 output is changing during the second clock pulse, when the output is changing from 0 to 1, which is nothing but positive change, positive edge trigger, so it won't trigger the output of the third flip-flop. So thereby there won't be any change in the output. Similarly, the change at the output of second flip-flop is 1 to 1, so there is no change at the output of a third flip-flop also. When the output of second flip-flop changing from 1 to 0, which is nothing but negative transition, then the output of third flip-flop is changing its state. It is toggled. Okay, similarly in the remaining clock pulses, then when there is no change at the output of third flip-flop, is also no change. When there is a change from 0 to 1, also there is no change in the output of the third flip-flop. Only it changes during when the output changing from 1 to 0, then only it is going to trigger the third flip-flop, and then only the third flip-flop will be toggled and change its state from 0 to 1. Okay, so if you observe and if the counting sequence, this is the MSB bit and this is a LSB bit. So MSB bit we count in reverse order. So this is a 0 and this is 1, this is 2, 3, 4, 5, 6, 7. Okay, after 7 again it is reset back to 0. So with the help of 3-bit up counter, we will count up to 8 clock pulses, means it will count up to 7. When the 8th clock pulse comes, again it reset back to 0. So this is about asynchronous binary up counter. We will discuss asynchronous binary down counter in the next session.